everyone, today I am here to explain you about the laws of chemical combination. At the end of this presentation, you will be clear with all the laws of chemical combination. The combination of elements to form compounds is governed by the following 5 basic laws. These are law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gaseous volumes, and Avogadro's law. Let's move to the first law, the law of conservation of mass. The law of conservation of mass was given by Antoine Lavoisier in 1789. According to the law, in a given chemical reaction, the total mass of the reactants is equal to the total mass of the products. Coefficients are added before chemical formulas in a chemical equation to ensure that the number of atoms on each side of the reaction are balanced. But later, when quantum mechanics was developed, it was found that in nuclear reactions, mass is converted into energy. Thus, this law is not valid for nuclear reactions. You will be more clear with this law by looking at the following examples. In example 1, 4 gram of hydrogen reacts with 32 gram of oxygen to produce 36 gram of water. We can clearly say that the sum of masses of reactants is equal to the sum of masses of products. Here, 2 in the reactant side and the product side is the coefficient which is used to balance the equation. In the next example, we have 16 gram of methane reacting with 64 gram of oxygen to produce 44 gram of carbon dioxide and 36 gram of water. In this reaction also, the sum of masses of reactants is equal to the sum of masses of products. Hence, we can say that the law of conservation of mass proves to be true for these reactions. Now let's move to the second law of chemical combination, that is, law of constant proportions or law of definite proportions. This law was given by a French chemist, Joseph Proust, in the year 1799. According to this law, a pure chemical compound, irrespective of its source or the method of preparation, always contains the same elements combined in a fixed ratio by mass. Proust worked with 2 samples of cupric carbonate, one of which was of natural origin and the other was synthetic. He found that the composition of elements present in it was same for both the samples. Thus, he concluded, irrespective of the source, a given compound always contains the same elements combined together in the same proportion by mass. But later, when isotopes were discovered, it was found compounds are formed by different isotopes of the combining element. Thus, it was a limitation of the law. Here are few examples by which validity of this law has been confirmed. In the first example, we can see the amount of carbon dioxide produced in all the experiments contains carbon and oxygen in the ratio 3:8, whether it was obtained by heating carbon with oxygen or produced due to decomposition of calcium carbonate. Similarly, in the next example, whether we take water kept in a bottle or tap water, its composition remains same, 2 hydrogen and 1 oxygen. Same is for any other compound, like ammonia, whether it is obtained naturally or prepared in lab, it will contain nitrogen and hydrogen in the ratio 14:3 only. Then comes the law of multiple proportions. This law was proposed by Dalton in 1803. According to this law, if 2 elements can combine to form more than one compound, the masses of one element that combines with the fixed mass of the other element are in the ratio of small whole numbers. For example, if we take 2 elements, nitrogen and oxygen, Nitrogen and oxygen combines together to form more than two compounds like NO, NO2, N2O, N2O2 and N2O5. Here, if we fix the mass of one element, let's say nitrogen, then the ratio in which oxygen reacts with nitrogen to form various compounds is in small whole number ratio. Let's see another example. Carbon and oxygen reacts to form two compounds, carbon dioxide and carbon monoxide. Here, if we fix the mass of carbon as 12, then the ratio in which oxygen reacts with carbon is in small whole number ratio, that is 1:2. Similarly, hydrogen combines with oxygen to form two compounds, namely water and hydrogen peroxide. Here, the masses of oxygen which combine with the fixed mass of hydrogen bears a simple ratio of 1:2. Therefore, in all the examples, one element combines with a fixed mass of the another element bearing a simple whole number ratio. Now let's talk about the fourth law, that is Gay-Lussac's law of gaseous volumes. This law was given by Gay-Lussac in 1808. Gay-Lussac's law of combining volumes of gases state that at constant temperature and pressure, the volumes of gaseous reactants and products can be expressed as ratios or small whole numbers. In the examples given, we can see that 2 volume of hydrogen combines with 1 volume of oxygen to give 2 volume of water. Thus, the volume of hydrogen and oxygen which combine bears a simple ratio of 2:1. In second example, the volume of nitrogen and hydrogen which combines bears a ratio of 1:3. Similarly, in next example, 1 volume of hydrogen reacts with 1 volume of bromine to give 2 volume of hydrogen bromide, bearing a ratio of 1:1 with each other. So now let's see the last law of chemical combination, that is Avogadro's law. This law was proposed by Avogadro in 1811. Avogadro proposed that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Avogadro explained the above result by considering the molecules to be polyatomic. Here are few examples to prove the law. In the following example, we can see that at standard temperature and pressure, all the gases, be it hydrogen, oxygen or carbon dioxide, contains same number of molecules, that is 6.022 into 10 raised to power 23 molecules, and the gas takes up a volume of 22.4 liter. In the next example, let's take 3 gases, namely argon gas, oxygen gas and nitrogen gas at constant temperature of 273 Kelvin and 1 atmospheric pressure. If we take 1 mole of each gas, then all the gases will contain same number of molecules, that is Avogadro number molecules, and same volume of 22.4 liter, irrespective of their mass. Though Avogadro's law was correct, it did not gain much support. Later, Avogadro's work got recognition. So, with this, our laws of chemical combination are completed. Hope you were able to understand the concept. Thank you. Presentation by Himanshi.